So this is what so these are the two things that we're gonna concentrate on today. Okay? So we're gonna take an exponential function and write it as a logarithmic function. We're gonna take a logarithmic function and write it as an exponential function. Okay, so y equals log base b of x. So let's look down here. If log base b3 of 27 equals y, then notice the 3 becomes the base, the y is the exponent, and it always equals that number. Okay? So I'm going to refer to the base. The base will always be the base. What in the logarithm or in the exponential function, b is always the base. Okay? And you know this because, look, you guys, y equals b to the x, b is the base. So, doesn't matter, logarithmic, exponential, b is the base. So the first two we're going to do is just basic. Let's write it in exponential form. So in number 1, what is our base? Our b. 4. The 2 is our y, and that becomes our exponent, and it equals 16. Okay? On example 2, what is our base? 3. What's our y? That becomes our exponent, and it equals 729. Okay? So that's how you go from logarithmic to exponential. Now we're going to do exponential to logarithmic. So again, the b, the small subscript, is your base. What it equals becomes your exponent, and then the x, or the big number, becomes your what it's equal to. So this is what we kind of did on Friday, except that we might have had an exponent. We might have had a variable there, okay, which we're going to get to. Okay, now I'm going from exponential, well, I'm actually going from exponential to logarithmics. So the first thing we're going to do is write log. Now, what is our base? 4, so that's going to be my subscript. What is my x? 64. And then what is my y? Okay? What is my log? So, I'm sorry, what is my base? So my base is 125. What is my x? 5. And what does it equal? Okay, so remember, b of x equals y, right? So when you write it, it becomes log b x equals y. There you go. There you go. Which makes sense because b was our base, so that's where the 4 went. 64 was our x, which was over here. I think I'm writing that wrong. But I know that's right. I'm going to look this up because I don't want to confuse you guys. Okay. Yeah, don't do that. Online. Okay, flip it over. I know it's right. I'm just not writing it correctly for you guys. Flip it back, you guys, here. So the first two went from this to this. The last two went from this to this. Okay. Now, let's evaluate. We're going to evaluate, and then we're going to practice, and then we're going to do some graphing. So, this is in a logarithmic base. It doesn't have a y, but we're going to act like it does have a y. So, the first thing we're going to do is we're going to rewrite it. So, this is in a logarithmic form, so we need to write it in exponential form. So, what is my base? Is there a y? No. So we're going to set it, we're going to make our y our variable. And what does it equal? 81. So now what you want to do is you want to think about it. This is just what we did like on Friday. Is there a way we can rewrite 81 so it has a base of 3? So, how many 3's, can we change 81 to a 3 and raise it to a power? So can you write 81 so it has a base of 3? What? Who said it? What did you say? 3 to the 4th power? And just like on Friday, our bases are the same, so y equals 4. Good so far? Okay, so let's look at number 6. What is our base? 1/2. What's our exponent? Y. And what is our x? What does it equal? Okay. So there's two things here. One, your base should never be a fraction, even though it can be, but we can rewrite the fraction, and we talked about this on Friday, so I just want to rewrite it for you, is that if you have 1 over a to the nth, that equals a to the negative nth. So what is my a? In this problem, what is my a? 2. What is my n? And we're going to make that -1y. And is there another way to write 256? What did you say? To the what power? 8. So we can rewrite 256 to 2 to the 8th. Now, are the bases the same? So I have 2, 2. So I'm going to set it up to -1y equals 8. What does y really equal? Y equals -8. Any questions over that so far? What kind of questions do you have? When we're going to do the graphing, all I want to do is base it on just your parent functions. Okay, that's all we're going to do. It's just parent functions. Tomorrow we'll talk about what happens if we have anything added or subtracted to it. So I just want to point out that your domain is all real numbers. Your range is all real numbers. It's going to be continuous 1 to 1. Your asymptote is always going to be the x-axis, and your y-intercept is always going to be 1, 0. What that means is these 3 points, you guys, no matter like where b is greater than 1, notice this is what your graph looks like. So those 3 points are the points that we will use continuously. So, okay. So notice that they both go through -1, 0. They both go through B1, and they both go through 1 over B comma -1. It just is a matter of where B1 is and where 1 over B -1 is. Okay? So, one other thing that you need to realize is that 2 to the y cannot equal 0. That's the first thing. And you can't have something like this. Yeah, those are undefined. You can't have anything like that. Okay? So when you go to graph your parent function, it's really important you know what your base is, because your parent function is all based on what the b is. So again, you guys, these 3 ordered pairs are going to be really important, because these are the 3 ordered pairs we're always are going to use, especially when we start talking about our shifts and our vertical and our horizontal stretches, okay? So the biggest thing is for both of these is, what is our B? That's the only thing that we really need to know right now. So what is our B in number 1? 2. So our base is 2. That is what we need to know. So now what we're going to do is I'm going to show you these ordered pairs. These ordered pairs, as long as it looks like this, you guys, this is what the ordered pairs will look like. Tomorrow, I'll tell you how to decipher what happens with our shifts. But right now, this is all we're graphing. Okay, so you guys, this is 1 over B. So what is our B in this problem? What did you tell me it was? 2. So this becomes 1 over 2, comma, -1. This ordered pair never changes. It's 1 over B, comma, -1. This always stays the same. It doesn't have any B, so we're going to leave it that way. And then what is B for this one? 2, comma, 1. So now what we're going to do is we're going to graph those 3 points. You guys, these never change. Those stay. Every logarithmic graph goes through those. Now, they might be adjusted when we do our shifts and our vertical and horizontal stretches. So 1/2, 1. So, I'm sorry, 1/2, -1. So we're going to go to 1/2, which is between -1 and 1, down to -1. So it's just going to go in the center. Okay? 1, 0, 1, 0, and then 2, 1, and then that's what it looks like. Okay. We're not looking for anything perfect. We are looking for a sketch. You guys, it is really important that you remember these 3 ordered pairs when you're graphing. Everything comes back to those 3 ordered pairs. Again, everything comes back to these 3 ordered pairs. Okay. What questions do you have? B was our base because that was the subscript, and then it's 1 over B and B, comma 1. Okay, let's look at number 2. What is our base? What is it? B equals 1/8. Okay. So again, our ordered pairs are 1 over B comma negative 1, 1 comma 0, B comma 1. Now, where this one takes effect is this one right here, the 1 over B. Well, it's 1 over 1/8. You guys, you can't leave it as 1 over 1/8. So I want to show you in your calculator. All you're going to do is 1 divided by, parentheses, 1 divided by 8. So again, 1 divided by 1/8 basically. And then what did you get? 8. So this becomes 8 comma negative 1. Because 1 over 1/8 turns into 8. 1 0 works. And then the last one is 1/8 1. Now you're going to see the difference in this one compared to what it was like. So when we go to graph this, it's 8 negative 1. It's 1 0. And then it's 1/8 1. And now it's going to go like this. You guys, the biggest difference is that first ordered pair. The one over B, that's what changes everything. You guys, our asymptote is that y-axis. So what I want to do tomorrow is we're going to take our quiz. You guys, the quiz isn't that big, but I want to go over some graphing. And then we'll probably take your quiz, we'll go over the graphing, and then you'll have time to work on your homework. I will tell you what your homework is tonight, so you know. It is in the workbook. What page did we just finish? 95? So your homework is page 96. Oh, look at that. I did print out the answers. Well, and you're going to do all of them. Now, with that being said, you're not really going to be able to do 21 and 22 just yet, but it is only 9:56. You have about 10 minutes if you want to start on page 96 to get your homework done. Tomorrow, we'll go graphing, quiz, and we'll start off with any questions that you might have.
Can you go to the restroom?